Science Chapter 17, Changing Energy Forms. You will discover what different kinds of energy are, what electric current and electric circuits are, how series and parallel circuits differ, how magnetic domains cause magnetic fields, and how electricity and magnetism are related. Chapter 17, Vocabulary: Energy, kinetic energy, potential energy, electric current, electric circuit, magnetic domain, electric motor, generator. You are there. You watch through a protective window as the high-powered laser light is turned on. Blinding sparks of hot metal shoot out in all directions. Energy from the invisible light beam changes to heat energy that melts a smooth cut in the metal. It's a good thing you're watching through a protective window. This laser delivers a lot of energy to a small area. Even the reflection of the beam would damage your eyes or skin in less than a second. How can energy change? Lesson 1. Energy exists in many different forms. Energy can change from one form to another, but it is never lost completely. Energy and work. Think of all the ways you change things. You change an apple by cutting it in half. You flip a switch to light up a room. Pushing a book changes its location. Every change involves energy. And energy is related to work. That's why energy and work use the same unit, the joule. When you do work, you change an object by transferring energy to it. Energy is the ability to cause change or to do work. Energy is a property of all matter. Forms of energy. Mechanical energy is the energy an object has because of its movement or position. Kinetic energy is the mechanical energy of a moving object. A ball rolling across the floor has kinetic energy as long as it keeps moving. Potential energy is mechanical energy due to position. Any object above the ground, such as your book sitting on your desk, has potential energy. Energy has many other forms. Chemical energy is stored in the bonds between atoms. You get chemical energy from the food you eat. A car's engine uses chemical energy stored in gasoline. The nucleus of an atom stores nuclear energy. This energy can be released when atoms break apart. Reactions like this take place in a nuclear power plant. Another kind of energy, thermal energy, moves from one object to another as heat. Electrical energy is energy that results from the movement of electrons. Televisions and lights rely on electrical energy. Describe 2 types of mechanical energy and give an example for each. So I want you guys to leave those in the comments. Remember, mechanical energy is the energy an object has because of its movement or position. Energy changes. Almost everything that happens around you involves the change of energy from one form to another. Think about the different forms of energy involved in drinking a glass of orange juice. The energy changes begin with the sun. The sun's nuclear energy changes to radiant energy that travels through space to Earth. The leaves of an orange tree take in this radiant energy. During photosynthesis, the leaves change the radiant energy to chemical energy stored in the plant cells. When you drink orange juice, you take in the stored chemical energy. Your body changes some of the chemical energy to thermal energy to keep you warm. Some thermal energy is lost to the air as heat. You change chemical energy to kinetic energy as you move around. All forms of energy can be used to create forces to do work. Think about the kinetic energy of moving wind and water. It can create forces strong enough to blow down trees or move rocks. Geothermal energy in hot underground springs can force geysers to spurt water high into the air. At the seashore, the energy of tides and waves results in forces that wear away sand and rocks. Each kind of energy can be changed into thermal energy. Rub your hands together. What happens? Do your hands get warmer? That's because of energy changes that result from friction. Friction causes the mechanical energy of your moving hands to change to thermal energy. Thermal energy also results when something burns. For example, chemical energy is stored in wood. When wood is burned, some of the chemical energy changes to thermal energy. The thermal energy may move as heat that warms the nearby air. Some of the chemical energy changes to radiant energy that warms you if you stand near burning wood. A geyser can release a lot of stored energy. What kind of energy are stored in each of these objects? I want you to leave that in the comments below. Conservation of mass and energy. In all of these energy changes, energy is never lost completely. It only changes form. Think about this example. If you drop a rubber ball onto a hard floor, the ball bounces a few times and then stops. Each bounce is lower than the one before it because the ball loses some energy as heat and sound. The energy lost from the ball is gained by the floor and the air. Until the 1900s, scientists had never found a process in which energy was lost. This fact had been observed so often that scientists called it the law of conservation of energy. Scientists also had stated a similar law about matter, called the law of conservation of mass. First discovered by Antoine Lavoisier in 1784, it stated that matter could not be created or destroyed. Then scientists discovered that energy and matter can be changed into each other under extraordinary conditions. For example, nuclear energy results when matter changes to energy. Because of this new evidence, scientists developed a new law that states that the total amount of matter and energy does not change. Both his firefly and the light wands converted chemical energy into light energy. Lesson checkpoint. Where do plants get the chemical energy they need to grow? Explain why the work needed to operate a machine must always be more than the work done by a machine. Hint, think about friction. And writing in science. Descriptive. Write a paragraph describing the energy changes involved in tossing a ball into the air. That's your homework assignment. You can answer it in the comments or you can email it to me.